Zombies are everywhere in pop culture lately, from the Walking Dead television series, popular best-selling books, even to a zombie romantic comedy, Warm Bodies, that came out recently. So with all the hullabaloo, we at the Office of Sustainability would like to conduct a thought experiment about the predicted effects of climate change on the zombie apocalypse. But before getting to zombies, it's critical to review what is known about climate change. Most climate scientists agree that the primary reason for recent rising average temperatures is an increase in the greenhouse effect. This describes how certain gases in our atmosphere prevent heat from escaping. Primarily, these are water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons. The composition of these gases affects the average temperature on Earth. The greenhouse effect is seen on other planets too. Mars has a very thin atmosphere that is nearly entirely carbon dioxide, but because of low atmospheric pressure and little or no methane or water vapor to reinforce the weak greenhouse effect, Mars has a largely frozen surface that shows no evidence of life. The atmosphere of Venus, like Mars, is nearly all carbon dioxide, but Venus has about 300 times as much carbon dioxide in its atmosphere as Earth and Mars do, producing a runaway greenhouse effect and a surface temperature hot enough to melt lead. Carbon dioxide is a minor but influential component of the atmosphere. It is released through natural processes like respiration and volcanic eruptions, but also from human activities like deforestation, energy production, and the burning of fossil fuels. Since the Industrial Revolution, humans have increased the concentration of CO2 in the atmosphere by a third. Many climate scientists think this helps explain recent warming of the planet. So are humans to blame? In its fourth assessment report, the Intergovernmental Panel on Climate Change, the IPCC, concluded there's a more than 90% probability that human activities have warmed the planet. Industrial activities have raised atmospheric carbon dioxide levels from 280 parts per million to 390 parts per million in the last 150 years. So what is actually happening to temperature? This graph shows the change in global surface temperatures relative to 1951 to 1980 averages. The long-term trend is clearly upward, which also correlates with increases in carbon dioxide since the dawn of the Industrial Revolution. In terms of Fahrenheit, the Earth's temperature has increased by about 1 degree during the 20th century. 1 degree Fahrenheit increase over a century doesn't sound like much, but it is unusual compared to the planet's recent history. Earth's climate record shows that the global average temperature is stable over long periods of time. Furthermore, small changes in temperature correspond to enormous changes in the environment. At the end of the last ice age, when the northeast United States was covered by more than 3,000 feet of ice, average temperatures were only 5 to 9 degrees cooler than today. 2012 was the warmest year ever recorded in the continental United States. NASA's Goddard Institute for Space Studies, GISS, in New York, monitors global surface temperatures on an ongoing basis. GISS climatologist Gavin Schmidt said, and quote, "One more year of numbers isn't in itself significant. What matters is this decade is warmer than the last decade, and that decade was warmer than the decade before." So what are the predicted effects of this warming? The IPCC estimates a temperature rise between 2.5 and 10 degrees Fahrenheit over the next century. As a consequence, the IPCC predicts a contraction of snow cover areas, increased thaw in permafrost regions, and a decrease in sea ice. Other predicted effects include a more than 90% probability of increased frequency of heat waves and heavy precipitation events, a more than 66% probability of increase in tropical cyclone intensity, and a likely decrease in water resources in semi-arid regions, including the western United States and Mediterranean basin. Which, don't ask me how, brings us to zombies. There are 4 definitions of zombie provided in Max Brooks' Zombie Survival Guide. We'll go with the first one, an animated corpse that feeds on living flesh. Zombies have no physical needs other than hunger. Their only drive is for human flesh, and this makes them much less dependent on and susceptible to environmental conditions than humans. Characteristics. Zombies have excellent hearing, they have sight like normal humans, a more acute sense of smell, and literally no physical sensations. The average lifespan of a zombie is estimated to be 3 to 5 years, depending on the rate of decomposition. Decomposition is where climate, particularly moisture and temperature, come into play. A zombie in a tropical climate will probably not last as long because of intense heat and moisture. This will increase the rate of decay of its flesh. A zombie in a cool and dry climate will decay more slowly. Everyone knows that at the beginning of the zombie apocalypse, the highest concentration of zombies will be in urban areas, because this is where most of their food, i.e. humans, will be located. Given the dense populations in these areas, outbreaks in cities will be the most severe. As time goes on, however, humans will be forced to leave cities in search of their own needs: food, water, and shelter. Zombies will inevitably follow. With many cities being located on the coast, the predicted sea level rise due to climate change could cause some urban areas to be underwater in the future. This will force humans to leave these areas, and zombies will inevitably follow in search of their food source. Unlike humans, however, zombies could continue to function in an underwater urban environment until dissolving, because they do not require oxygen. This photo is of Mississippi floodwaters surrounding a home near Vicksburg. The increased occurrence of floods is one of the many predicted consequences of a warmer planet. Looking at this from the perspective of the zombie apocalypse, one might think this home would be safe from zombies because of the water. However, zombies are essentially all-terrain creatures, and in the apocalypse they will inhabit almost every environment on the planet. Without having physical sensations like humans, zombies do not react to weather extremes. They will not seek shelter during what are predicted to be more frequent and more intense tropical storms, twisters, and heavy precipitation events. This will aid humans in that these severe weather events will likely increase the rate of zombie decay. However, they may also inhibit crop production. Another effect on crop production is expected to be insects. The warmer temperatures associated with climate change will influence insect populations, in most cases by increasing them. Populations in mid to high latitudes are expected to develop more rapidly and survive longer because of lower winter temperatures. This will also allow them to expand their range. In relation to the zombie apocalypse, the effect of the insect population explosion is a double-edged sword. It is good for humans in that some insect species will feed on zombies. However, it will also negatively impact crop production, and some insects like mosquitoes carry disease. Imagine if a mosquito bites a zombie and then a human. Will the infection spread like malaria or West Nile virus? Though zombies do not react to weather, they are still subject to freezing in colder climates. With climate change predicted to cause Arctic snow-covered regions to contract, zombies would have greater freedom of mobility in areas where they might before have frozen in search of food. Zombies will also benefit from precipitation decreases in tropical regions, because this will slow decomposition. In addition, zombies will be indirectly affected by changes in freshwater availability in so much as it affects movements of humans, who they always follow. To conclude, climate change is mostly good for zombies, and therefore bad for humans.